So failure criteria. First you will write what is meaning of failure. What is the meaning of failure? Failure doesn't means that part will be fractured into two parts. Okay. So failure can be considered first by fracture of the element, or you can say element breakdown into two parts. And second, deformation of element. Deformation of element. Okay. So when we call it deformation means permanent deformation. Deformation बोले तो permanent deformation. So here when we call it that, when we found that element or member has been break down into two parts, so this will be the failure of first kind. The part has been break down into two parts, so it will be called failed part. But failure is not always due to breakdown into two parts. Failure can also be considered if deformation of element is beyond the permissible value. Beyond the permissible value. Okay. So first criteria we check with the help of stresses. So this will be called your strength criteria. And here we check with the help of deformation or stiffness. This will be called your stiffness criteria. Okay. So here you can write, या इसको I will make it right now. Write down failure of element doesn't mean that it will break down in two parts always. If permanent deformation will be more than acceptable value, it will be also called failed element. Or useless. Failure means useless part that has become useless for us. For example, let's say this is a bar. And it is running in a machine. Initially its length is L and dia is D. Okay. Now it is running in the machine. Okay. Running in the machine like this. And the space in machine, generally you see it is very closely packed. The fits tolerances are very less, 0.001 mm like this. Okay. So let's say its initial dia is 30 mm. And initial length is, let's say, 300 mm. and this part is running, and in the running condition there is compressive load here from both sides. There is compressive load here from both sides, and load is very high, let's say 10 kilonewton. 10 kilonewton. But the stresses induced in this will be compressive, and compressive stresses are much less than the your failure value. But if its dia will increase because there is compressive load, length will decrease, dia will increase like this. Let's say इसका dia है that has been increased to a new value like this. Dia increase, okay, let's say it has become d dash, and d dash is, let's say, 31 mm. 31 mm, and there is not so much space available in the machine so that it can rotate further. So there will be a starting jamming of the member in the machine. Got the point or not? So this may get jam in the machine. Machine will be jammed. Okay. So this part will be called a failed part, or you can say useless part for us. Okay. So failure का मतलब ये नहीं है कि पार्ट हमेशा टूट जाएगा, either in tension or compression or shear. Rather, if the value of permanent deformation will go beyond the acceptable value, this is also failed part for us. Clear everyone? Draw the figure. Draw the figure. Length will decrease, dia will increase, length will decrease, dia will increase. So it will be failed part for us. Done? Okay, good. So in the failure criteria, there are first one. Here we will consider the stresses value. This will be called strength criteria, and this will be called your stiffness criteria. So write down the first heading, strength criteria. Strength criteria. Okay. And this criteria is the old criteria. Okay. And here we are considering only for static loading. Considering only for static loading. So when your material will be ductile material, the stress induced or applied or working stress induced or stress applied or working stress, okay, this must be less than equal to the sigma yt of the material. Sigma yt is what? Strength. So in the machine design, learn first thing, that is very important. This is also stress, this is also stress, but this is the induced stress or applied stress or working stress. मतलब ये कौन सा स्ट्रेस है? लगाया वाला. लगाया वाला. लगाया वाला means applied. You are applying. Okay, and this is what, this is also stress, but this is the stress up to which material can sustain. So this stress is actually strength, this is its yield टेंसाइल strength. तो ये है झेलने वाला, कौन सा है, झेलने वाला, मटेरियल इतना झेल सकता है. झेलने वाला मीन्स द मैक्सिमम वैल्यू अप टू विच मटेरियल कैन विदस्टैंड. विदस्टैंड मीन्स झेलने वाला है. तो अगर लगाया वाला झेलने वाले से कम है, ओके, इन हिंदी, शुद्ध हिंदी, लगाया वाला इफ लेस देन झेलने वाला, then material will be fail or safe? Safe actually. So these are not actually failure criteria, these are actually safety criteria. Material will be safe here. Okay. Second, if your material is brittle, material is brittle, and in brittle material the induced stress or the applied stress or the working stress is less than equal to ultimate strength of the material, then again it will be in safe zone. This is again safe. Got the point or not? It must be less than this. It must be less than this. Okay. Now, what does this means? Yield in tensile and ultimate. After the ultimate, material will fail. Okay, so there will be sudden failure in case of brittle. In strength of material, we know the curve of ductile material curve will be like this, and brittle material curve will be directly failure here. So for the brittle material, this is the value of sigma ut. Yes or no? So when stress will reach ut, beyond ut, it will damn sure failed in two parts suddenly. There will be total and sudden failure. Yes or no? And in case of ductile, stress you are considering only yield strength. Yield strength means yield strength will be here only. Fracture will be here, but yield strength, upper yield strength will be here only. Why we are considering here fail? Because here the after this yielding will start. Yielding means permanent deformation will start. If permanent deformation will start, this part will be considered failed. It is not break down into two parts. Okay. So here you can write yielding. What is the meaning of yielding? Yielding means permanent deformation. Permanent deformation beyond acceptable value. Acceptable value. And permanent deformation can be of different type. It can be elongation, it can be compression or contraction, or it can be shear. It can be shear also, or you can say distortion. Shear mein it is called distortion. Okay, contraction or compression or shear or elongation. Got the point or not? Okay. So in case of ductile material, if stress will be just beyond the yield strength, the failure will be considered. Failure will be considered. So for the this we have done. For the next criteria, stiffness and rigidity criteria. Now, here we will not check the stress. Here we will check the value of deformation. Deformation, or you can say deflection. Deflection. This deformation is not the permanent deformation, it is simply deflection of the member. Okay, and it is also we are considering for static loading only. So in this case, the maximum deflection, or you can say maximum linear deflection, we study in strength of material slope and deflection. So deflection y max must be less than equal to permissible value. Then only the part or member will be safe. And maximum slope theta max, this must be also less than equal to theta permissible value. Theta permissible value for the safety. Then these will remain safe. Then these will remain safe. For example, just like we have seen in the strength of material also, let's say there is a flat platform like this. There is a flat platform like this. On this platform, let's say swimmers, or you can say Olympic, in the Olympic games, some player is going on this platform and he will reach here. After that, he will take few jump. He will take few jump here itself. Then he will make a permanent jump and go like this, or जाकर he will get into the water. So let's say this is the sport, and the rule of sport is when his jump will be more, he can take more number of turn before touching the water. Okay, so the person who will take more number of turn before touching the water in the pool, he will be called winner. So this platform will be actually flexible platform. This will not be rigid platform. Yes or no? So this will be flexible platform. So there will be a, limit, allowable limit for the deflection. Y max, this much should go down and this much should go up. So there will be a set limit for this. So specific material will be selected for this platform. So let's say here the maximum range allowed, let's say 1 feet. 1 feet it should go down and 1 feet it can go up. Only then swimmer or this player can jump here and get more lift with the help of spring effect of the platform. Yes or no? If it will be very stiff, like rigid, he cannot get the jump. Then he should only jump from here. That's it. So what is the use of this platform? इसका use क्या होगा? It must be flexible. So there will be certain range of deflection here. Let's say this is the maximum permissible value. Let's say this is the maximum permissible value for the deflection, Y max. Okay, Y max must be here. If आफ्टर लॉन्ग यूज ये प्लेटफॉर्म जो है वो 2 4 10 सालों तक यूज किया जा रहा है, 10 years लेट से, आफ्टर मैनी ईयर्स द मटेरियल क्वालिटी विल डिटेरियोरेट. yes or no? Material quality will degrade. So this can become more flexible. When same weight player will go here, then the deflection will be more than permissible value and player can fall down directly into water. Yes or no? So that part is not breaked into two parts, but it will be replaced. It will be replaced because it is of no use. So it is become useless for us. Yes or no? बात समझ आई? तो ये डायग्राम बना दो सो दैट यू विल रिमेंबर होल स्टोरी, so that you will remember whole story. So stiffness criteria or rigidity criteria, this is also called our modern criteria. Modern criteria. Okay. Modern criteria. Next, for the fatigue loading, fatigue, or you can say fluctuating loading. So in case of fatigue loading or fluctuating loading, the applied, induced or applied or working stress must be within limit with respect to endurance strength of the material. Okay, endurance strength of the material. So where sigma E is called endurance strength. What is this? We will learn in second chapter. How to decide endurance limit or endurance strength. Then the material will be or member will be considered safe. Okay. This is for fluctuating or fatigue loading. Next case, in case of buckling. Okay. So failure criteria for buckling. So in case of buckling, we will not check the stress. In case of buckling, the load value is checked. Okay, and buckling is only for compressive load. Only for compressive load in long column. अभी ये चैप्टर अपना हुआ नहीं है सोम में. When you will learn, there we will discuss complete theory of it. It is only for compressive load. Tensile load cannot produce the buckling, and it is applicable only for long columns, because in case of short columns buckling load will be very high, so that will not be seen. Okay, so in this case the applied load must be less than the buckling load. Buckling load, because buckling load in case of long column will be lesser than the crushing load. Will be lesser than the crushing load. Okay, when columns are long, crushing बहुत बाद में start होगा. Before crushing, buckling started, and if the applied load is less than the buckling load, the column will be considered or member will be considered what? Safe. What the point or not? It will be considered safe. Okay, done up to this.